Hi everyone, I'm Lily, a computer science PhD student, and I'll be talking about visualizations, specifically visualization literacy, and how we're moving toward a more comprehensive understanding of it all. So visualizations are the charts or the graphs you might encounter in your everyday media consumption, such as from news outlets, and here are some examples. Visualizations are all around us, so visualization literacy is becoming more important than ever. Now, there are two questions that I want to bring to your attention today. What is visualization literacy exactly, and how can we measure it? Visualization researchers in the community have studied this and essentially defined visualization literacy to be the ability to read, interpret, and extract information from visualizations. And they use questions like this to measure people's ability to perform the fundamental visualization tasks. So let's give it a try. The question here asks, over the course of 2013, the average price of a pound of coffee beans was rising, falling, or constant. So one way that someone might approach this problem is first finding the range on the x-axis that we're interested in, which in this case is 2013, and that gives us this region to focus on. Looking at the visual representation here, it seems to be going down. So we would be choosing falling in this case, and that is indeed the correct answer. Cool, but that's not the only visualization in the world, so let's try a new visualization with a similarly formatted question that says, from 2005 to 2007, the number of visitors at the museum was rising, falling, or constant. Applying a similar strategy as before, we would first find 2005 to 2007 on the x-axis, and that gives us this region to focus on. And looking at the three dots here, it seems to be going down. So we would be choosing falling, right? Let's take a closer look at the y-axis here. It seems to be inverted, and that can cause some issues. But we can fix this by flipping the entire visualization around like this. That kind of fixes it, but at least the y-axis is not inverted anymore, and now we see that it's actually going up. And rising would be the correct answer here. So we have seen two example questions here. How are they different exactly? Well, the first difference is that the left-hand visualization came from an actual assessment that's been developed to measure visualization literacy. And the second difference is that there is no inverted y-axis here, or any other errors at all. In other words, the visualizations used in the previous tests developed to measure visualization literacy are assumed to be correctly designed. But we argue that this assumption does not necessarily transfer to the real world, because not all visualizations in the real world will be correctly designed. This brings up other questions like, are these tests comprehensive enough to measure visualization literacy? And how can we develop a more comprehensive measurement for visualization literacy? Now let's bring back the second visualization from the second example. This is a remake of a real-world visualization that appeared in 2014. And looking at this, we already know that flipping the entire visualization can kind of fix the inverting y-axis problem. But this is not the only way a chart can mislead. Let's take a look at another example here with a truncated y-axis on a bar chart. The y-axis here starts at 34%, making the bars look drastically different. But if we look at the numbers on the bars, 35% versus 39.6%, they're not that different. And starting the y-axis at 0% shows a more accurate representation. And there are many, many more like this. When charts are sending misleading messages, this is something called visualization misinformation, and this does happen in the real world. And some of these are specifically designed to go against our assumptions. If someone were to use one of these visualizations to make decisions or help with problem solving and did not notice the misleading components, then that can cause some very poor decisions and negative consequences. Thus, we need to have the ability to identify visualization misinformation when it happens, and not just accept every visualization as it is. And this ability needs to be part of visualization literacy. We are taking steps toward a more comprehensive understanding of visualization literacy. Circling back to the two questions we started with, visualization literacy is more than just reading or extracting information from visualizations. It needs to include the ability to correctly navigate around these erroneous or potentially misleading visualizations. And we are extending beyond current assessments for visualization literacy to include questions that's able to measure people's ability to critically interpret visualizations. Or in other words, we are including the critical thinking aspect of visualization literacy. With a more comprehensive understanding and a more comprehensive measurement for visualization literacy, we can then develop interventions that can help us maintain a well-informed community. Thank you.